In this video, we will learn the sustained interference. Here, interference of light is being shown by using three examples. First one, where both waves are in phase and having zero phase difference as shown. And when they both will superimpose, we will get the resultant wave and the amplitude will be 2a and the resultant intensity is 2a square, which is 4a square, and resultant intensity is 4 times of the intensity of the incident wave as shown. Now if we will discuss the second example where path difference between the two waves is 2 lambda. Now, phase difference can be found by using this relation. This relation can be obtained by using unitary method. Here we are having one wave and the phase difference of one wave path difference is 2 pi as written here. And by using unitary method, the phase difference of one path difference will be 2 pi by lambda, and the phase difference of delta x path difference will be 2 pi by lambda into delta x. Now using this relation in this situation, we got two equation of the wave where phase difference between them is 4 pi as shown. And in the next example, if the path difference is 0.5 lambda as shown here, then by using the same relation we can find the phase difference between the two waves is minus 5 pi, and we obtain two equations y1 and y2 by putting the value of phase difference as shown here. Now by using these three examples we can obtain the general equation for the constructive and destructive interference. Here in the case 1 and 2, the path difference was 0 lambda and 2 lambda, which can be obtained by n lambda, and phase difference can be obtained by using the formula which is 2n pi. Now for destructive interference case 3, where the path difference was 2.5 lambda, which is generalized by the formula 2n plus 1 lambda by 2, and the phase difference can be obtained 2n plus 1 pi by using the formula here. Here the first case, the second case for constructive interference, and the third case is for destructive interference. So we have obtained the general conditions for constructive and destructive interference. Here we are discussing the general case where we have used two equations for two waves, and by adding them we have obtained the equation by using the identity cos c plus cos t, and by putting all the values here we have reached to the final result where 2a cos phi by 2 is the amplitude of the resultant wave. So the intensity of the resultant wave is obtained here. From here we can find the condition of maxima and minima. Maxima means the 4 I naught intensity which is obtaining at phi 2n pi, and minima is obtaining at phi 2n plus 1 pi. Now, young double slit experiment is shown in the figure where two slits and one screen is there, and both are separated by capital D distance, and two slits are separated by small d distance, and these two waves are interfering at point P. Now by using the formula of path difference for constructive interference which is n lambda, and by putting directly the formula of path difference x small d by capital D, we have obtained xn, which is the position of bright fringe from the center. Now for the dark fringe we have put the formula of the power difference to n plus 1 lambda by 2. And again, by putting the same relation of the power difference here, we have obtained the position of the dark fringe xn, which is 2n plus 1 lambda d upon capital D, which is from the center of the screen. Now, intensity distribution curve is shown here, which shows the position of maxima and the minima. Here, we have obtained this pattern only if the sources are coherent, that is, constant or non-varying phase difference and same amplitude and frequency, which is for monochromatic light, and if the sources are not coherent, we cannot obtain sustained interference pattern, which is shown for incoherent sources. The only brightness will be obtained on the screen as shown in the graph. No dark and bright fringes will be obtained in the case of incoherent sources. Thank you.